Hi, my name is Amara Chubu, and I'm back again for the week 7 sovereign video of my learnings at Web3bridge. So this last week, we wrote 5 smart contracts, and there were Mercury smart contract, auction, lottery, to do, and voting smart contract. So the main aim of the smart contracts, writing smart contracts, they came as assignment was for us to really test our hands and know how good we are so far. So I'm going to go over the concept of how I did mine, and then also drop the links to my solutions in the description below. So for the auction smart contract, so basically my owner was auctioning an NFT. So the whole idea was the seller of the NFT is the one to create the auction. So and they are the only one to start the auction after creating it. So when at the point of creation, they're sending their smart contract. They're sending their NFT into the smart contract, and then after that, that's only when bidders are allowed to bid. So and bidders are allowed to bid from a minimum value, and the next bidder is not allowed to bid lower than the previous bidder. So and there's an elapsed time, and the bid is allowed to hold up until the elapsed time. So once the elapsed time reaches, the highest bidder is the one to get the NFT, and then the seller is the one to get the money. So and then the person to end the bid can be anybody, so that the seller can end the bid, and then the highest bidder can also end the bid. So when you end the auction, so when you end an auction, basically the money is sent to the seller, and then the NFT is sent to the highest bidder. And then there is also options for other bidders who were not the ones that got the NFT at last. So we draw back their funds that they put into the smart contract. So that's for the auction. And then we also had the Mercury. So the Mercury was basically to verify that a particular address was actually whitelisted to collect an NFT. So that was the whole concept. So I used a library from OpenZeppelin that does the Merkle proof. So we just have to provide the hashes that is needed to hash to get to the point in the Merkle root. So that was what the Merkle proof was actually doing. And then we also did voting smart contract. So here at the point of creating the smart contract in our constructor, we set our candidates. So candidates are the people that voters are voting for. And then once that is done, voters is giving us rights to vote by the chairperson, which is the owner of the contract, as person that created the contract. And they can vote once they are given the right to, or they can delegate their vote to another voter. So how delegation works is you give your vote to another person, and that person it has a higher weight to vote. So if the person had the weight of 1 to vote earlier, and then you delegate your vote to the person, that means the person can vote his one when he votes once, it counts twice, right? And so on and so forth. So the more they are delegating to that particular person, the person has more weight to vote. And that's it for the at the end of the day, you can check the winner by calling a function, and so on and so forth. Then we had our lottery smart contract. So just like the basic lottery, a lottery is created and players start playing, and at the end of the day, a winner is chosen at random. So that's the basic rundown of what the lottery does, and they are just helper functions to get the players, to get the winners, and the final get the balance of the smart contract, which is actually what the winner of the lottery would get, because as players are coming to play. They are coming to play with a particular amount, and then at once the lottery ends, a user is chosen at random, and the person chosen is only the admin can choose the person to get the money at the end of the lottery. Which other one have I explained? I've explained voting, lottery, okay, to do. So to do is just like the basic smart contracts that you write in every programming language you learn. So basically, just create a list of tasks that you can update, and then you can toggle if you've done that actual task or you've not done it. So that's a basic rundown of what the whole smart contracts that we worked on. So I'm going to leave the link in the description so you can go ahead to check it out. Thanks for watching, and look out for a video from me